Okay, so hello students. So I hope all of you are doing well. So today we'll see a very interesting and very important phenomena of quantum mechanics, and that is Young double slit experiment. I hope all of you have studied this experiment. So today we'll see this one. See, all of you know that quantum mechanics, we know this thing that at microscopic level we use the concept of quantum mechanics, right? And this is a general perception that quantum mechanics is all about the wave particle duality. It's a very general perception that a wave is associated with a particle, so a wave can behave like a particle and a particle can behave like a wave. And this is all about the quantum mechanics. This is a general perception. But let me tell you one thing, this is not the quantum mechanics. This is the one aspect of quantum mechanics. Quantum mechanics is something else. And today we'll see this thing by this experiment. So first we will do this experiment and then you will feel that yes, it is completely different thing. You will feel the weirdness of quantum mechanics. Fine. So let's start with this experiment. So this experiment all of you perform in either in your BSc or MSc laboratory also by using the light. So very simple experiment. So first we will do this experiment with the light. So let's suppose we have a light source here. Let's suppose this is a light source. Light source. So of course it is emitting the light in all the directions. Now what we do, we'll put the two slits just in front of the light source. We just put two slits. Let's suppose this is slit S1 and this is slit S2, right? So there are two slits just in front of this light source. Now of course, and we put one screen. Let's suppose this is the screen. Now see what will happen. Let me use the different color. So you see, when light is passing through these slits, and we'll see some pattern on the screen. Now see, let's suppose initially slit S2 is closed. Let's suppose S2 is closed. So what will happen? The complete light will pass through S1. When the light will pass through S1, what we'll see? We'll see that light is, you see a bright spot at this point. Just in front of the slit S1 you will see the bright spot, right? This kind of bright spot you will see. Fine. And I can represent this bright spot like this. This is the intensity of this bright spot. This is how you can represent. Fine. This is the first case when S1 is open only and S2 is closed. Now let's take the second situation when S2 is open. Then what will happen? When S2 is open and S1 is closed. So of course the light will pass through S2 and you will see a bright spot just in front of the S2 here. This is the bright spot of light and you can represent the intensity like this. Fine. Now, what will happen when both the slits are open? When S1 and S2 both are open. So, when both slits are open, you will find both are open. So, when both the slits are open, then this kind of pattern you will see. You will see a bright spot, then dark spot, then again bright spot, bright spot, bright spot, bright spot, and so on. So you see light, no light, light, no light, and so on. So I can represent it like this. So you'll see this kind of pattern, and you know this is nothing but the interference pattern, right? So we are getting that from the slit S1 and S2 the light is passing and that light interfere with each other, and you will see this interference pattern. Of course, if it is a constructive interference, then you will see the light. If there is a destructive interference, you will see no light. So light and no light, fine. So this is the well-known concept. This shows the wave nature of light. This shows the wave nature of light. This is a very well-known concept. Now what we do, we'll perform the same experiment with the particles, and then we'll see that what will happen. So let's do the same experiment by using the particles. Now what we do this time, we'll change this light source with the particles. So let's take some particles. Let's suppose now this time you have some small particles. Fine, very small. आप कोई भी seeds use कर सकते हैं, ठीक है? So same kind of thing, I can put the slits. Fine. Let's suppose this is S1, this is S2, and this is our screen. Now what are you doing? You are throwing these particles. Let's suppose आपके पास एक gun है and you put the particles inside that gun, ठीक है? And you are shooting those particles on this slit S1 and S2. For example, let's suppose you have 1000 number of particles. Now let's suppose again same case. First case is, let's suppose S2 is closed. So what will happen? All the particles will pass through this slit S1. So what will happen? They will be collected at this point in front of S1, and I can represent this number of particles. This again shows the intensity of particles, or I can see the number of particles. So all the particles will be collected at this point. Fine. So this is the first situation. Again this is S1 is open. Second situation is also same. When S2 is open, so what will happen when S2 is open and S1 is closed? So again the particles will be collected in front of S2. ठीक है? Now what will happen when both the slits are open? What will happen in this case? And remember, this time you are using the particles. So क्या होना चाहिए? Think about it. Technically क्या possible है? What should be the expected thing? आप इसे इस तरह से समझिए. Let me use this. Just wait. Let's suppose you have these two slits. You can see this one. I'm just writing the name. Let's suppose this is slit S1 and this is slit S2. Right? So we have slit S1 and S2. So you are putting it like this. And you are throwing the particles on this slit S1 and S2. The first case slit S2 is closed, so you are getting this situation. Second case you are getting this one. Now if both the slits are open, then what will happen? If both the slits are open, you are throwing the particles. So what will happen? Let's suppose you have 1000 number of particles. So some of particles will pass through S1 and some of the particle will pass through S2. कुछ यहाँ से जाएंगे, कुछ यहाँ से जाएंगे, right? Let's suppose for the simplicity, I am saying that 500 particles are passing through S1 and 500 particles are passing through S2. The ratio may be different, but we'll see this kind of pattern. That sum of particles will be collected in front of S1 and sum of particles will be collected in front of S2. वेरी सिंपल, यही होना चाहिए था. फाइन. नाउ लेट्स टेक द थर्ड सिचुएशन, सेम वन, same thing. Let's change these small particles. See, this time these are the small particles. You can take any macroscopic particles. जैसे आप कोई भी seed use कर सकते हैं. ठीक है. Now let's change this particle with electrons. And let's suppose this is an electron gun. Now you are shooting the electrons. So we know electrons are also particle. तो जो भी पैटर्न सीड्स के थ्रू आया था will get the same pattern with the electrons, right? Again, when S2 is closed, S1 is open, electrons will be collected at this one. When S2 is open, electrons will be collected at this point. When both S1 and S2 are open, then of course what will happen? Some of the electrons will pass through straight. Some of the electrons will pass through S1 and some of the electrons will pass through S2. So हमें क्या है? This should be our expected outcome. When both are open, this is the expected output. Simple है कि कुछ इलेक्ट्रॉन यहां से जाएंगे, कुछ यहां जाएंगे. We will see this kind of pattern. But this time, when you are using the electrons, instead of this pattern, you will see this kind of pattern. Very interesting thing. You will see this kind of pattern. This is the actual output. Now this is very interesting thing. This is the interference pattern. It means, can I make this statement that we are getting the interference pattern from the electrons? And interference is the purely phenomena based on the wave nature, based on the waves. So from this experiment I can say that electrons are behaving like a wave, right? This is the experimental evidence of de Broglie hypothesis. What is de Broglie hypothesis? That there is a wave associated with every moving particle, right? So electrons are behaving like a wave. But आप देखिए सीड्स के केस में वहां तो आपको ऐसा नहीं मिल रहा था, वो भी तो एक पार्टिकल है. And we know that with every moving particle there is a wave associated. तो सीड्स के केस में तो ऐसा नहीं हुआ, इलेक्ट्रॉन के केस में ऐसा क्यों हो गया? Why? That is because of the size. Because those seeds have macroscopic size. जैसे मान लीजिए आप दो सिचुएशन ले लीजिए. Let's suppose these seeds and let's suppose mass of one seed is let's suppose 50 ग्राम का कोई भी एक पार्टिकल ले लिया. एंड लेट्स सपोज फॉर द केस ऑफ इलेक्ट्रॉन वी नो द मास 9.1 इंटू 10 टू द पावर -31 kg, राइट? इसको भी आप केजी में लिख लो. लेट्स सपोज 0.01 ग्राम केजी, राइट? नाउ लेट्स ट्राई टू फाइंड आउट द वेवलेंथ. व्हाट इज द वेवलेंथ करस्पॉन्ड टू दिस सीड? h/mv. And let's suppose both are moving with the same velocity. Let's suppose 4 into 10 to the power 4 meter per second. You can put these values 6.64 10 to the power -34 divided by 0.01 into 4 into 10 to the power 4. So approximately what you will see around -38 approximately. This is the wavelength, -38 meter. And for the case of electrons, we will find out this into 10 to the power -34 divided by 9.1 into 10 to the power -31, 4 into 10 to the power 4. Now you see you can cancel this. So this is around 10 to the power -7 meter. Now you see this is the wavelength associated with the electron, and this wavelength we can easily measure -7. But you see, in case of this seed, the wavelength is -38. You cannot measure this wavelength experimentally, right? तो इसीलिए हम बोलते हैं कि with the macroscopic particles there is no wave. It doesn't mean कि wave associated नहीं है उसके साथ. There is a wave associated with every moving particle, कितना भी size हो, कुछ भी हो. But the thing is, if size is increasing, then wavelength is decreasing. ठीक है? तो जब size बहुत ज्यादा हो गया तो wavelength बहुत कम हो गया. Then we can simply ignore that wavelength, and that's why we are not getting the interference pattern with the seeds. But with the help of electrons, you are getting this pattern, right? So this is the experimental evidence of de Broglie hypothesis. So this is all about the wave particle duality. I can prove this thing, but now we'll see the interesting thing. Now what you do, now see the third situation. Second situation, now see the third situation. Instead, say in this case, we are sending the bunch of electrons. We are throwing the bunch of electrons because these are electron guns. You are shooting the bunch of electrons. एक साथ बहुत सारे इलेक्ट्रॉन्स आके जा रहे हैं स्लिट्स पे. तो पॉसिबल है कि सम, जैसे मान लीजिए कि 500 इलेक्ट्रॉन्स यहां से गए, 500 यहां से गए. So what will happen? And there is a wave associated with these particles, these electrons. तो क्या होगा, जो इलेक्ट्रॉन यहां से जा रहे हैं और जो यहां से जा रहे हैं, उनके साथ जो waves हैं, they will interfere with each other, and you will see this kind of pattern. So this is basically the interference of waves. Now let's see the third situation. In this case, you are sending the electrons one by one. This is very interesting. You are sending the electrons one by one. What is the meaning of one by one? You just shoot the electron, so only one electron will be ejected from this gun, and that electron will pass through these slits, right? And it will reach at the screen. ठीक है? जब फर्स्ट इलेक्ट्रॉन स्क्रीन पे पहुंच जाएगा, उसके बाद हम फिर सेकंड इलेक्ट्रॉन शूट करेंगे. रिमेंबर, दिस इज वेरी इंपॉर्टेंट. When first electron is reaching at the screen, after that we will shoot the second electron. So we are sending the electrons one by one. अब आप मुझे बताइए कि इसमें क्या होना चाहिए था. What should be the outcome? Forget about these two situations. Of course, if slit S1 is open, so that electron will pass through S1. If S2 is open, the electron will pass through this S2. No problem with this. What will happen with this situation when both are open? So very simple thing, again you can understand. S1 and S2, right? You are sending only one electron. तो क्या possibility है? That electron either pass through S1 or S2. किसी एक से वो जाएगा. मान लीजिए कि हमने माना कि फर्स्ट इलेक्ट्रॉन, देखिए मैं इसे हटा देता हूं एक बार. Let me just remove these two things. So let's suppose this is our screen. Now we are sending the electrons one by one. So let's suppose the first electron is passing through S1. So we can collect that electron at this point in front of S1, right? This is our electron. Then you shoot the second electron. वो भी मान लीजिए S1 से ही चला गया, so it will be collected at this point. Then you again shoot the electrons. Let's suppose that is passing through S2, so you can collect the electron in front of S2. ऐसे करके आप electrons one by one भेजते जाइए. So what will happen? Some of the electron will pass through S1, so you can collect those electrons here, and some of the electron will pass through S2. You can collect those electrons here. So this should be our output technically, right? क्योंकि एक ही इलेक्ट्रॉन जा रहा है तो ये S1 से जाएगा, S2 से जाएगा. So you will see this kind of pattern. This is our expected pattern. But again, very interesting thing and very weird thing will happen now. Then when you are sending the electrons one by one, again after some time you will find this kind of pattern. This kind of pattern. Now how you will explain this thing? How you will explain this thing? See, in the second case we are sending the bunch of electrons. तो क्या हो रहा है वहां पे, कुछ इलेक्ट्रॉन S1 से जाएंगे, कुछ S2 से जाएंगे, और वो दोनों आपस में इंटरफेयर करेंगे, एंड देन यू विल सी दिस काइंड ऑफ पैटर्न. बट दिस टाइम वी आर सेंडिंग ओनली वन इलेक्ट्रॉन. एक इलेक्ट्रॉन जा रहा है और स्क्रीन के पास पहुंच गया. देन विल सेंड द सेकंड इलेक्ट्रॉन, and again we are getting the interference pattern. How this is possible? So can I say this thing that electron is interfering with itself? एक इलेक्ट्रॉन एक ही टाइम पे S1 से भी जा रहा है और S2 से भी जा रहा है. बट दिस इज नॉट पॉसिबल. कैसे पॉसिबल हो सकता है कि एक इलेक्ट्रॉन सेम टाइम पे S1 और S2 दोनों से जा रहा है? बिकॉज देन ओनली इट इज पॉसिबल ना कि यहां से भी जाए और यहां से भी जाए, देन इट इंटरफेयर विद ईच अदर. बट हम तो एक ही इलेक्ट्रॉन भेज रहे हैं, राइट? सो यू कैन नॉट एक्सप्लेन दिस थिंग बाय दिस वेव नेचर. सो यू सी दिस थिंग, इट्स अ वेरी वियर्ड थिंग. नाउ वन मोर इंटरेस्टिंग थिंग इज, चलिए यहां तक भी चीजें ठीक है कि एक एक इलेक्ट्रॉन जा रहा. हमने कहा वी कैन से दिस थिंग that electron is the interfering with itself. This is the interference of electron with itself. हमने ये मान लिया. But now one more interesting thing. Now what I do in this case, I will put a detector here. This is the detector. See, because this is a very interesting thing. We want to see this thing. इस तरह का पैटर्न आ रहा है तो हम क्या चाहिए? हम देखना चाहते हैं कि वो इलेक्ट्रॉन S1 से जा रहा है या S2 से जा रहा है. वी वांट टू ऑब्जर्व द पाथ ऑफ दैट इलेक्ट्रॉन. तो हमने क्या किया? वी पुट ए डिटेक्टर इन द फ्रंट ऑफ स्लिट S1 एंड S2, नियर टू द स्लिट S1 एंड S2, एंड वी आर ऑब्जर्विंग दिस पाथ ऑफ इलेक्ट्रॉन. तो क्या होगा? अगेन वेरी इंटरेस्टिंग थिंग विल हैपन नाउ. व्हेन यू पुट द डिटेक्टर, then you will get this kind of pattern. ये क्या हुआ? Unexpected thing. See, we are not changing, we are not doing any kind of change with the experiment. कुछ छेड़खानी नहीं की हमने एक्सपेरिमेंट के साथ. Everything is same. We are sending the electrons one by one, right? इनिशियल केस में डिटेक्टर नहीं था तो हमें इस तरह का पैटर्न मिला. विदाउट डिटेक्टर. बट अब जब ये पैटर्न मिला तो क्या चाहिए? वी वांट टू सी द पाथ ऑफ इलेक्ट्रॉन कि एक्चुअली में वो S1 से जा रहा है, S2 से जा रहा है. हम उसे देखना चाहते हैं. तो फॉर दैट वी पुट ए डिटेक्टर. नो, जैसे ही आपने डिटेक्टर पुट किया, यू विल फाइंड दिस काइंड ऑफ पैटर्न. अब इसे कैसे एक्सप्लेन करोगे? व्हाट इज हैपनिंग नाउ? देयर इज नो चेंज इन द एक्सपेरिमेंट. हमने तो सिर्फ एक डिटेक्टर पुट किया है जस्ट पाथ को देखने के लिए. डिटेक्टर के रखने से ऐसा क्या हुआ कि इलेक्ट्रॉन ने अपना नेचर ही चेंज कर लिया? यू सी, ये इस तरह का पैटर्न कब मिलता है आपको? जब इलेक्ट्रॉन पार्टिकल की तरह बिहेव करे. और ये पैटर्न कब मिलेगा? जब इलेक्ट्रॉन वेव की तरह बिहेव करे. So what is happening here? When we put the detector just to observe the path of electron change its nature. Getting my point? जैसे ही आपने डिटेक्टर पुट किया, इलेक्ट्रॉन ने अपना नेचर चेंज कर दिया, पार्टिकल नेचर शो करने लग गया. अब जैसे ही आप डिटेक्टर हटाओगे, फिर से इस तरह का पैटर्न आएगा. इट मींस इलेक्ट्रॉन इज नाउ बिहेविंग लाइक अ वेव. तो डिटेक्टर के रखने से ऐसा क्या हो रहा है कि इलेक्ट्रॉन अपना नेचर ही चेंज कर रहा है. वेरी वियर्ड थिंग, राइट? This is beyond the wave particle duality, right? You cannot explain this thing now just assuming the wave particle duality of electron or any particle. You cannot explain this thing. This is something else. Now you feel this anxiety that what is actually happening here, right? Here you study this uncertainty principle, that you cannot measure the position and wavelength, position and momentum of a particle simultaneously. That means you cannot track the motion of particles. Same thing is happening here. When we put the detector, then we want to measure the path of electron, and that is not allowed in quantum mechanics. जैसे आपने डिटेक्टर रख के इलेक्ट्रॉन का पाथ मेजर करने का ट्राई किया, इलेक्ट्रॉन ने तुरंत अपना नेचर चेंज कर दिया। इसका क्या मतलब है? इट मीन्स इलेक्ट्रॉन नहीं चाहता कि कोई उसका पाथ ऑब्जर्व करे, कोई उसका नेचर ऑब्जर्व करे। वेरी सिमिलर लाइक टू द ह्यूमन नेचर। यू सी, एवरी पर्सन हैज इट्स इंडिविजुअल नेचर, उसका एक अपना नेचर होता है, बट इन फ्रंट ऑफ पीपल that person behave differently. In different person you always behave differently, right? हर एक के साथ आपका बिहेवियर अलग होता है, इंडिविजुअल नेचर आपका अलग होता है, पेरेंट्स के साथ अलग बिहेवियर होगा, दोस्तों के साथ अलग होगा। सेम थिंग इज हैपनिंग विद द इलेक्ट्रॉन। इलेक्ट्रॉन नहीं चाहता कि उसका जो एक्चुअल बिहेवियर है, उसका जो एक्चुअल पाथ है, वो कोई ऑब्जर्व कर पाए। अब आप पूछ सकते हो कि ऐसा क्यों हो रहा है? Nobody knows. But this is the reality. See, these are the experimental evidences. These are not the theoretical things. These are experimental evidences. Now, if you stuck this kind of situation, in this kind of situation, how you will explain this? Right? So right now I am not explaining this thing. You feel this anxiety, you feel this weirdness, and try to find out the answer. Think about it, right? Just fight with yourself, with your perception, and think about it कि ये क्या हो रहा है, ऐसा क्यों हो रहा है। Fine? So I hope आपको समझ में आया होगा कि this is some quantum mechanics is something else. This is not only the wave particle duality, that is only one aspect. Quantum mechanics is something different. Fine? So try to find out this answer. Okay? So I hope you like this discussion. So अगर आप चाहते हैं I will explain this phenomena, that what is happening here, then write down the comment section. In the next video I'll explain this thing. Fine? I hope you like this discussion. Also like, share and subscribe our channel. Fine? Okay, bye.
अगर आपको ये वीडियो पसंद आया हो तो लाइक, कमेंट, शेयर एंड सब्सक्राइब आवर चैनल।